Magic Treehouse, Tsunamis and Other Natural Disasters by Mary Pope Osborne and Natalie Pope Boyce. Dear readers, we saw on television how a horrible tsunami took many lives and destroyed property. We realized that we didn't know exactly what caused tsunamis. Then we started to talk about other disasters. We knew a little about volcanoes and earthquakes, but not enough. We had seen pictures of landslides and avalanches, but we needed to know exactly why and how they occur. So we decided to write a book about natural disasters like these. Tracking down the facts took a lot of time, but the good news is that there is tons of helpful material out there. There were hundreds of excellent websites about natural disasters, and there were loads of books in the library. In fact, we had almost too much information. We sat down and discussed what we had learned. We filled many notebooks and wore down lots of pencils. We spent hours printing out articles and pictures. Whew! It was a lot of work, but it was also really fun. We still say that tracking facts is like taking vitamins for the brain. Jack and Annie. Chapter 1. Disaster. On December 26, 2004, Tilly Smith, a schoolgirl from England, was on vacation with her family. They were visiting an island off the coast of Thailand. The day was bright and sunny as Tilly and her family walked along the beach. The ocean appeared calm and clear. But as she walked, Tilly noticed that the water suddenly seemed odd. Waves rolled in with foam that looked like it was sizzling in a frying pan. The surface of the water seemed to bubble. Waves came in, but they didn't go back out again. The beach was getting smaller and smaller. Suddenly, Tilly remembered what she'd learned in school just 2 weeks before. The class had been studying the huge waves called tsunamis. Tilly remembered the warning signs of a tsunami. She got really scared. These were the signs she'd learned about. She started screaming. Tilly's parents ran to her side. She told them what her teacher had said in class. Tilly and her parents rushed up and down the beach screaming for everyone to run. Then they raced to warn people in the hotel. Everyone scrambled for safety. Tilly and her family climbed to the 3rd floor of the hotel. Minutes later, a wall of water crashed onto the beach. 3 huge tsunami waves struck, one after the other. The sea seemed like an angry monster. Everything in its path was gobbled up. Tables and chairs landed in the pool. Palm trees toppled over. But Tilly and her family were safe. The water did not destroy the hotel. Thanks to Tilly and her parents, many other people survived as well. Tilly meets former President Bill Clinton on a visit to the UN in 2005. Tilly had been part of a terrible natural disaster. This disaster was caused by an earthquake many miles away. The earthquake took place in the Indian Ocean. It set off one of the worst tsunamis in history. 2 hours after the earthquake, giant waves hit the coast of Thailand and Indonesia. Hours later, waves reached the coast of southern India and East Africa, more than 5,000 miles away. When it was over, around 300,000 people were dead. 2 months later, rescue teams were still finding over 500 bodies a day. Natural disasters. Tsunamis and earthquakes and volcanoes can create natural disasters, terrible events caused by nature. Weather causes some natural disasters like hurricanes and tornadoes. But tsunamis, earthquakes, and volcanoes begin deep inside the earth. For many years, scientists knew little about the way the earth worked. They could not explain the exact reasons for earthquakes, tsunamis, and volcanoes. They were puzzled about why these things happened in some places and not in others. The scientists did research for many years. Then, 40 years ago, a group of scientists came up with some ideas. These ideas came from clues they saw on the ocean floor. What they concluded may be hard to believe. They said that the ground we stand on is actually floating, and it's moving. These movements can cause major natural disasters. It's in the stars. The word disaster comes from Latin and Greek words for stars. The word for star in Latin is astrum. In Greek, it is astron. We get the English word astronomy from these words. Astronomy is the study of outer space and the objects in it. Today we know the reasons for most natural disasters, but long ago people thought the position of the stars could cause terrible things to happen. They constantly studied the stars, the moon, and the sun, looking for signs that bad luck was on the way. Chapter 2. Earthquakes. Earthquakes happen both underwater and on land. Each year, there are about 1 million earthquakes all over the world. Most earthquakes last only a few seconds. They are not dangerous. People usually don't even feel the earth moving at all. The great earthquake that caused the tsunami of 2004 lasted about 10 minutes. Earthquakes begin beneath the Earth's surface. The Earth is made up of different layers. The outer layer that we live on is called the crust. The crust is made up of rocks and dirt. In most places, the crust is about 25 miles thick under the Earth's surface. The crust is thinner under the ocean. There is about 6 miles thick. The middle layer of the Earth is called the mantle. The mantle is about 1,800 miles thick. The mantle consists of super hot rocks. These rocks are not exactly solid, but they're not exactly liquid either. Rocks in the mantle are like a thick paste. Deeper down in the mantle, many of the rocks get so hot that they melt. This melted rock is called magma. There are two parts of the core, the deepest layer of the Earth. There is an outer core and an inner core. The outer core is about 1,400 miles thick. It is made up of melted rocks and metal, mostly iron and nickel. The inner core is about the size of our moon. It is mostly made up of super hot metals. The temperature of the inner core can be over 6,000 degrees. That's hotter than anything you can imagine. Plate tectonic theory. Scientists have found that the Earth's crust is not made up of one solid piece. It is made up of different sections. These sections come in different sizes and shapes. Scientists call the sections plates. They have a theory about the plates called the plate tectonic theory. A theory is an explanation based on lots of research. 9 large plates and many smaller plates form the crust. Scientists describe the plates as huge platforms of rock and dirt. They fit together a little bit like a jigsaw puzzle. The platforms or plates actually float on top of the mantle. Scientists have concluded that the plates move. Experts believe the moving plates cause earthquakes and volcanoes. They also believe that the moving plates created some of our great mountains. Movement of the plates. The plates move very slowly. In fact, they move about as slowly as your fingernails grow. When moving plates meet, 3 things can happen. Some plates slide past each other. When they slip past, they rub against each other. When plates move away from one another, it's called rifting. At times, the plates collide. Sometimes when this happens, one plate slides under the other. This is called subduction. What causes earthquakes? The point directly above where the earthquake occurs is the epicenter. The epicenter is often at the edge of moving plates. As the plates slide past each other, they cause a break in the Earth's surface. This break is called a fault. When the plates move, rocks break off. This creates edges that are rough and jagged. As the plates continue to move, the edges of one plate can get stuck on the edges of the other. When the edges come unstuck, a huge amount of energy is suddenly released. This powerful force causes the earth to shake. These movements are called seismic waves. Seismic means that the movements are caused by an earthquake. Earthquake waves move on average about 16,000 miles per hour through rock. The waves move fastest through colder rock. They slow down in sand, water, and warmer rocks. During a big earthquake, the ground seems to turn into jelly. The earth shakes from side to side and rolls like waves in the ocean. Sometimes the earth cracks. Cars bounce up and down. Windows break. Buildings crumble, sometimes trapping people inside. Entire cities can tumble into ruins after only a few minutes of shaking. Following an earthquake, aftershocks can occur for days, weeks, and even months. If you are ever in an earthquake, you'll never forget it. How earthquakes happen. Plates move, collide, pull apart, brush together, slide under one another, energy released. Measuring earthquakes. Scientists use an instrument called a seismograph to measure movements deep inside the earth. There are seismographs all over the world. Seismologists know an earthquake is underway when the seismograph records rapid, strong movement near the edge of a plate. Experts describe an earthquake's strength by using numbers on the moment magnitude scale. The earthquake that caused the 2004 tsunami was a magnitude 9.3. Earthquake. Not all earthquakes create tsunamis. Earthquakes happen on land as well as underwater. Some of the most powerful earthquakes have been on land. They have killed thousands of people and destroyed whole cities. California and Alaska have the most earthquakes in the United States. In 1906, a terrible earthquake nearly destroyed the city of San Francisco, California. The epicenter was near the downtown. The shaking only lasted about a minute. Buildings began to collapse. Victims were trapped under the rubble. As the buildings toppled, they killed people in the streets. Gas lines broke. Terrible fires raged out of control. Firemen ran out of water. To stop the fires from spreading from building to building, the firefighters blew up some of the buildings with dynamite. As fires spread through the damaged city, people began to flee for their lives. They tried to carry all their belongings with them. Some used baby buggies, wagons, and go-karts. Others carried trunks and suitcases. The loads were too heavy for many. Soon, trunks and household items littered the roads. Many people lost everything they owned. Much of the city was a smoking ruin. It took years after the earthquake before San Francisco returned to normal. Today, it is a beautiful city that tourists visit from all over the world. Earthquake safety. Predicting an earthquake is not like predicting the weather. Even with good instruments, no one can tell exactly when an earthquake will hit, and no one is sure how much damage will result. You will probably never be in an earthquake, but if you are and you feel the ground shaking, do these things right away. Take cover under a table, in a doorway, or in a closet. Stay away from heavy objects that could topple over, such as bookcases and refrigerators. If you are outside, get away from buildings and power lines. If you hear a hissing sound or smell gas, leave quickly. Chang Hen's urn. About 1,800 years ago in ancient China, a man named Chang Hen designed a special urn to measure earthquakes. The urn had 8 dragon heads on top, each with a ball in its mouth. 8 frogs with open mouths sat beneath. When the ground shook, so did the urn. 1 or more balls fell into the frogs' mouths. When Chang Hen saw a ball had fallen, he concluded there had been an earthquake. He thought he could tell how strong the earthquake was by the number of balls in the frogs' mouths. He thought he could tell where the epicenter was by which side of the urn the balls were on. Chang Hen's urn could actually show that the earth had moved. It could also give an idea about how strong the movement was, but it took thousands of years before scientists could tell exactly where an earthquake's epicenter was and how strong the earthquake had been. Chapter 3. Tsunamis. Tsunami means harbor wave in Japanese. Some people call tsunamis tidal waves. But tides do not create waves. Most waves come from wind moving over water. Tsunami waves come from deep down in the ocean. They are usually caused by an underwater earthquakes or landslides or volcanoes near or under the sea. Events like these change the ocean floor. They force a huge amount of water up to the surface. Waves begin to spread out in all directions. They travel very quickly, some as fast as 500 miles per hour or more. In fact, if Alaska were rocked by a quake, a tsunami could reach Tokyo faster than a jet plane. But if you were in the middle of the ocean during a tsunami, you would scarcely notice a ripple. In the open ocean, tsunami waves are usually only 1 to 2 feet higher than normal waves. Sailors rarely notice any change when the waves pass under their boats. Tsunamis hit the shore. When tsunami waves reach land, scientists say the waves begin to feel the ocean bottom. The waves start out to slow down, but as they slow down, they grow in height. It's just like a traffic jam. When cars are bumper to bumper, if a speeding car plows into them, a huge chain of crashes occurs. The waves begin to bunch up together. A 2-foot wave can become a 200-foot wall of water. That's as tall as a 10-story building. Most people think a tsunami looks like a huge wave, but from the shore, the ocean surface looks flat. People can't tell that danger is rushing toward them. Sometimes there are clues that a tsunami is on the way. One clue is that the water pulls back a long way from the shore. This is called a drawback, but sometimes the tide urges in and doesn't go back out again. The water seems to bubble and foam. Boats close to shore bob violently up and down. Tilly Smith saw some of these things and knew trouble was on the way. Tsunami damage. A strong tsunami can cause major destruction. When the wave hits, the force can kill people as they try to flee. Many drown as they struggle in the water. Others are sucked out to sea as the waves retreat. 5 days after the 2004 tsunami, a woman named Malawati was found alive clinging to a palm tree. She was 100 miles out to sea. Malawati was brought to a hospital in Malaysia after her rescue. Homes, buildings, and roads wash away. Electricity lines are downed. When the tsunami is over, it leaves behind tons of litter. Trees, mud, garbage, and even bodies are everywhere. And to make things worse, sometimes the water floods areas where tanks filled with chemicals, oil, and gasoline are stored. It also breaks sewer lines. When these things happen, the water becomes polluted. People are at high risk for illness and infection. Tsunami warning. In 1964, a tsunami hit Alaska and Hawaii. After that happened, U.S. scientists created a tsunami warning system. Since earthquakes cause most tsunamis, seismographs are a big part of the warning system. Seismographs record the strength of a quake. The scientists also put satellites in orbit to keep track of the height of the ocean. Since most tsunamis in the United States happen in Hawaii, the state has an excellent warning system. There are also systems in place in Alaska, California, Oregon, and Washington state. There are usually several hours between the earthquake and the time a tsunami reaches the coast. That's enough time to alert people that a tsunami is on the way. Warnings go out on radio and TV. Sirens blare out along the shore. Everyone knows to head for safety. Tsunami safety. If you are on the beach and hear sirens, run to higher ground as fast as you can. If you have time when you leave your home, take water, food, a portable radio with batteries, and a good flashlight. Listen to the radio. Don't go back home until you hear it is safe. Beware of the ocean. If it looks strange, remember Tilly. Animal warnings. For hundreds of years, people have noticed that animals get restless before earthquakes. Before the 2004 tsunami hit, there were reports that dogs refused to go out. Bats flew around nervously during the day, and flamingos and other seabirds flew up to higher ground. On the coast of Sumatra, elephant trainers claimed their elephants began to cry. Then the elephants broke their chains and headed for the hills. Scientists wonder if someday we can find a way for animals to actually help predict earthquakes. And if they can predict earthquakes, they can also warn us about tsunamis. Chapter 4. Volcanoes. The word volcano comes from Vulcan, the Roman god of fire. When we think of volcanoes, we often think of cone-shaped mountains spewing out fire and ash. But volcanoes come in different sizes and shapes. Some are tall mountains. Others are cracks in the earth. Still, others are gentle slopes with a crater on top. Volcanoes are a vent or opening in the Earth's crust. Hot melted rock erupts from the vent. Volcanoes form near the edges of plates. When subduction occurs, the lower plate can be pushed into the mantle. The temperature rises. New magma begins to form. Magma is lighter than solid rock. It begins to rise up into the crust. Magma rises through passages called conduits. The pressure from the rising magma builds up. It forces the magma bits of rock, gas, and ash through the crust. When they reach the surface, the volcano suddenly erupts. Magma escapes from the opening of the volcano. When the magma hits open air, it is called lava. Types of eruptions. Not all volcanoes explode violently. The type of eruption depends on the lava itself. There are two kinds of lava. One type is thin and runny. Thin lava does not cause violent eruptions. It oozes slowly from the vent. The second kind of lava is thick and sticky. It plugs up the volcano. Gases and steam are trapped under the magma. A huge amount of pressure builds as the gases and steam try to escape. The gases behave like a bottle of soda when you shake it. Pressure builds up. When you open the soda, the pressure is released, and you'd better watch out or you'll get soaked. In a violent eruption, the mountain suddenly explodes when the gases break free. Clouds of gas, ash, and rock shoot high into the air. Poison gas, ash, and lava pour from the volcano. When volcanoes erupt many times over millions of years, all of these eruptions build up and form mountains. Destruction. Violent eruptions can cause earthquakes, floods, tsunamis, mudslides, and rock slides. People can suffocate from poison gases. They can be injured or killed as rock and ash pound down on their heads as they try to flee. At times, the eruption creates a deadly mixture of fast-moving hot gases and pieces of dead hot rock. It can travel over 50 miles an hour. Scientists often call this quick-moving eruption by its French name, Nue Ardente, or glowing cloud. In AD 79, Mount Vesuvius in Italy violently erupted. The Roman town of Pompeii was buried under 6 feet of ash. But what really finished the town was the pyroclastic flow that followed. A hot blast of hot ash and gas barreled down the mountain. It destroyed everything and everyone in its path. The same thing happened in 1902 on the island of Martinique in the West Indies. Mount Pelée erupted. A pyroclastic flow roared down onto the town of St. Pierre. About 40,000 people died in this terrible disaster. Climate changes. Volcanoes can change the climate. After a big eruption, volcanic dust drifts high into the sky and spreads out over the planet. The dust filters out the sun. The whole world feels the effect. Days become darker and colder. In 1815, Mount Tambora on an island in Indonesia erupted. So much volcanic dust clogged the air that it hid the sun. Temperatures all over the world dropped. It even snowed in parts of the United States in June and July. Shield volcanoes are very large. The top looks like a giant bowl or shield. When shield volcanoes erupt, the lava seeps out slowly and can travel for hundreds of miles. Cinder cones. Cinder cones are the most common type of volcano. In an eruption, the lava is shot so high into the air that it cools into cinders. The cinders settle around the vent, creating an oval cone with a crater on top. A cinder cone volcano doesn't usually get very tall. Composite volcanoes. Some of the most beautiful mountains on Earth are composite volcanoes, or stratovolcanoes. Composite means made up of different parts. These are steep volcanoes that reach great heights. They are made up of layers of rock, lava, and ash from many eruptions over the years. They have craters at the tops. Composite volcanoes have thick lava that usually erupt violently. This makes their eruptions very dangerous. Mount Fuji is a dormant composite volcano. It is the highest mountain in Japan. The crater on top is over 1,600 feet wide. Over the years, many artists and writers have admired this beautiful mountain. Volcanic activity. Scientists describe volcanoes as being active, dormant, or extinct. Active volcanoes are ones that have recently erupted or could erupt soon. Scientists think there are around 500 active volcanoes on land. There are more than 1,500 beneath the sea. Dormant volcanoes have not erupted in a long time but could erupt again. Extinct volcanoes are ones that have not erupted for thousands of years, and scientists think they would never erupt again. Volcanologist. Scientists who study volcanoes are called volcanologists. They do research in laboratories, but they also spend time at volcano sites and collect samples of lava and gas. Volcanologists also check temperatures around the volcano. Some volcanoes are very hot. The volcanologists have to wear heavy suits for protection. The suits are coated with metal to reflect the heat and keeps the scientists from getting too hot. Katia and Maurice Kraft were two famous French volcanologists. In 1991, they were checking a volcano in Japan. Suddenly, it erupted. Their bulky suits prevented them from escaping. Sadly, both scientists died in the eruption. Pericutine. A baby grows up. In 1943, a Mexican farmer was working in his field. To his surprise, he spotted an opening in the earth. It was about 150 feet long. Then he heard a big noise like thunder. Suddenly, the earth began to swell. Dust and ash came drifting out of the opening. The farmer had discovered a baby volcano. Scientists named it Pericutine, after a local village. Pericutine didn't remain a baby volcano for very long. By its first birthday, it grew to over 1,000 feet tall. Chapter 5. The Ring of Fire. The Pacific Ocean covers almost half the Earth. Most tsunamis, volcanoes, and earthquakes occur in or near the Pacific Ocean. In fact, 90% of all earthquakes take place in the Pacific. They happen in an area called the Ring of Fire. The Ring of Fire is a huge semicircle that runs along the edges of the Pacific Plate. The Pacific Plate is a larger plate under the ocean that is expanding. It borders many other plates. The plates often push into one another or pull apart. These movements cause most of the earthquakes and volcanoes in the Pacific. Underwater volcanoes. There are thousands of underwater volcanoes in the Ring of Fire. Scientists recently began exploring these volcanoes using underwater robots and small research submarines. Underwater volcanoes can be tall mountains or openings on the seabed where lava oozes out onto the ocean floor. Sometimes metals erupt from the volcano. Instead of mountains, this creates tall chimney-like structures. The hottest are called black smokers because the metals that form them are dark. The water is very warm around these openings. Scientists have discovered interesting sea life around the underwater vents or black smokers. Sometimes underwater volcanoes grow up past the surface of the ocean. This creates chains of volcanic islands. Hawaii, Japan, and the Philippines are all volcanic chains. Mauna Loa in Hawaii is the largest underwater volcano in the world. It rises about 6 miles from the seafloor and is about 72 miles wide. The Ring of Fire has produced volcanoes and earthquakes for thousands of years. Natural disasters in the past have caused big changes in the way the Earth looks today. Disaster at Chicxulub. 65 million years ago, an asteroid crashed off the coast of Mexico in what is now the village of Chicxulub. The asteroid made a crater over 100 miles wide. Heat and flames from the asteroid started terrible fires. They burned from Mexico into what is now the United States. Dust and smoke clogged the air. Temperatures all over the world dropped. Plants and animals died by the millions. The impact of the asteroid also created terrible tsunamis that hit coasts from Haiti to Florida. At the same time, the dinosaurs became extinct. Today, many scientists wonder if this gigantic disaster caused the extinction. The Beast Under Yellowstone. Every day, tourists in Yellowstone National Park watch plumes of hot water shoot out of the ground high into the air. These are called geysers, and they come from underground volcanic activity. The world's largest active volcano lies under the park. Some scientists call it the Beast because it is so huge. About 600,000 years ago, the volcano erupted in a monster explosion. Entire mountains blew away. Whole herds of animals died for hundreds of miles around. The volcano left a giant caldera, or huge bowl-shaped hole. It has filled in with grass and dirt. Today, most of the caldera lies under Yellowstone Lake. Scientists think this gigantic volcano will erupt again someday, and they aren't sure when. Toba, the supervolcano. Toba is a large volcano in Indonesia. Scientists call Toba a supervolcano. Supervolcanoes have extremely violent eruptions. Toba's last major explosion occurred about 75,000 years ago. It was the largest volcanic eruption in the last 2 million years. When it erupted, thick ash blocked the sun. The sky turned black. Even the rain was black. For years afterward, temperatures dropped. Plants began to die. Most of the people all over the world died. Those who survived are your ancestors. Today, a beautiful lake lies in Toba's crater. Scientists say Toba is still alive, but not to worry. They don't expect Toba to erupt anytime soon. The lost continent of Atlantis. 2,000 years ago, the Greek philosopher Plato wrote about a continent that disappeared. He called it Atlantis. Plato had heard stories of Atlantis. The stories told of an advanced culture destroyed by an earthquake and floods. Today, scientists are almost sure that Atlantis was actually the Greek islands of Santorini and Crete. A volcanic eruption and tsunami wrecked parts of these islands 3,000 years ago. Experts are uncovering cities on the islands. They have named the people who lived there the Minoans. What the experts have uncovered gives them clues that the Minoans did indeed have a wonderful and rich civilization. The destruction of Lisbon. In 1755, Lisbon, Portugal, was a beautiful city. On November 1st, almost everyone was in church for a religious holiday. Suddenly, there was a terrible noise. It sounded like thunder. A large earthquake shook the city. All the great churches and buildings caved in. Fires raged through the streets. Shortly afterward, tsunami waves slammed into Lisbon's harbor. The lower part of the city completely disappeared. Experts estimate that at least 60,000 people died, more than a third of the population. In a matter of hours, most of the beautiful city was gone. Six, landslides and avalanches. In 1991, Mount Pinatubo in the Philippines erupted. Huge mounds of ash piled up around the volcano. Ash drifted out over the fields. Rain turned the ash to mud. This created a mudslide. It began to rush down the mountain. People below were trapped under the heavy mud. Over 700 people died. In 1970, a magnitude 8 earthquake caused an avalanche in the mountains of Peru. The avalanche roared down the mountain at over 100 miles per hour. It rolled right over the town of Yungay. Experts think that up to 66,000 people may have died in the earthquake and avalanche. Landslides, mudslides, and avalanches claim lives every year. These disasters cause billions of dollars of damage. What makes them happen? Can we do anything to protect ourselves? Landslides and mudslides. Landslides and mudslides happen when rocks, dirt, or mud slide down a hill or mountain. Heavy rain, volcanoes, or earthquakes can set off some landslides and mudslides. Others happen when people cut down trees on the hillsides or there are wildfires. The hillsides become bare with nothing to hold the dirt down. If it rains a lot, the dirt turns into mud. Gravity causes the loose dirt and mud to move down the slope. Some landslides and mudslides move slowly, but others move quickly, taking everyone by surprise. Mudslides usually happen after heavy rainfalls or snow melt. If it rains after a volcano has erupted, lava and ash turn to mud. The mudslide that results is called a lahar. The worst landslide ever recorded happened on May 18, 1980, when Mount St. Helens in Washington state erupted. Before the eruption, there was a magnitude 5.1 earthquake. The earthquake caused a landslide on the north slope of the volcano. The landslide tore down the mountain at speeds up to 150 miles per hour. It plunged into Spirit Lake. All of the water in the lake was pushed out. 600-foot waves crashed into a ridge. As the water settled back into the lake, it pulled thousands of fallen trees with it. But that's not all. The volcano's eruption melted snow on top of the mountain. The snow turned into water. The water mixed with the lava and ash coming out of the volcano. Soon, a giant lahar slid down the mountain. It destroyed 200 homes, 47 bridges, and 185 miles of road. Landslide safety. Landslides and mudslides cause 25 to 50 deaths per year in the United States. There are things people can do to protect themselves. If you live on a steep slope, listen to the radio and TV during heavy rains. Beware if mud starts to trickle down the slope. Watch streams to see if the water levels suddenly change. Move to high ground, especially if you see trees leaning to one side farther up the slope. If a slide happens suddenly, get under a table or any strong piece of furniture. Avalanches. Avalanches are a mix of rock, snow, dirt, and ice. They travel quickly and suddenly down the steep sides of mountains. Avalanches happen often. There are about 250,000 a year in the Alps mountain range in Europe. France has held the world avalanche record for the past 10 years. Many of the avalanches in the United States happen on the West Coast. For the past 6 years, Alaska has recorded the largest number. Large avalanches contain lots of snow. The snow could fill 20 football fields 10 feet deep. Imagine being caught in that. The most dangerous avalanches are called slab avalanches. They form when a soft or weak layer of snow cannot hold the snow layers that covers it. An avalanche expert in Utah describes the slab avalanche as a dinner plate sliding off a table. Slab avalanches travel fast, more than 60 miles per hour. You could never outrun one. Blame the snowflakes. Under a microscope, snowflakes look like stars with 6 points. No two are the same. When snow falls, new layers of snow put pressure on the snow underneath. This pressure makes the points on the snowflakes rounder. The crystals don't lock together as tightly. Gravity forces the snow to slide down the slope. An avalanche is on the way. Avalanches increase when the weather warms up during big snowstorms. The melting snow, or the new snow on melted layers, makes the snowflakes unable to bind together. One layer loosens and gravity pulls it and everything on top of it down the slope. Earthquakes, rainstorms, and volcanoes can also trigger avalanches. People can even set off avalanches if they disturb unstable snow. Most of the avalanches that kill snowmobilers and skiers are accidentally set off by the people themselves. If you plan to ski or snowmobile on a mountain, tell people where you're going and don't go alone. Sometimes there are signs posted that say danger, avalanche. Don't go into these dangerous areas. If there are no signs, look for cracks in the snow. Then listen for noises. The snow may sound hollow as you thump it. You may also hear the snow make whumping noises. If you hear noises like this, it's time to leave. If it's too late and an avalanche is on the way, you will feel a strong avalanche wind. This is moving air pushed ahead of the avalanche. If the avalanche hits, there are still a few things you can do. Avalanche safety. Let go of any ski poles you might have. Quickly tighten your clothes to keep the snow out. If possible, grab hold of a tree or rock. When the snow covers you, make kicking or swimming motions to try and work your way back to the top. It's not likely you'll get hit by an avalanche. Each year, only about 150 people die in avalanches around the world. But always remember something else. Information is your friend. A timeline of some modern disasters. December 26, 2004. South Asia suffered a deadly tsunami. It killed over 30,000 people. The exact number may never be known. November 13, 1985. Colombia suffered from a volcano and mudslide. About 25,000 died. In July 28, 1976, Tangshan, China, was hit by an earthquake while people slept. Over 655,000 people died. May 22, 1927, Qinghai, China, lost about 200,000 people in a deadly earthquake. September 1st, 1923, Tokyo and Yokohama, Japan, lost about 140,000 people in an earthquake and resulting fires. Seven. To the rescue. Skilled rescue teams from all over the world rush to help in times of disaster. Many teams are made up of volunteers who give their time and skill to help. Doctors and nurses set up tent hospitals to treat the injured. Planes begin to arrive with blankets, food, water, tents, and medicine. There are even teams that come in to rescue animals. People skilled in finding victims in the ruins of buildings arrive. Engineers bring heavy equipment to remove rubble. And all over the world, people send money, food, and clothing to the victims. Rescuing people. The first challenge the teams face is getting people out of fallen buildings. Rescuers shout through bullhorns to the trapped people. They tell them to tap on whatever they can reach. As the victims tap, a device called a life detector senses where the noise is coming from. Rescuers then try to reach the victims. Another helpful instrument is a search cam. This is a special camera that can take pictures through small holes. The rescue team drills holes into the chunks of concrete that surround the trapped people. They guide cameras into the holes. The cameras send back images of the people trapped inside. Some of the best rescuers aren't people, they're dogs. Dogs have a much greater sense of smell than people's. Rescue dogs are trained to smell victims trapped under buildings or even snow. One avalanche expert said that one dog is worth 20 people in finding an avalanche victim. Being on a rescue team isn't easy. Aftershocks can shift buildings, trapping rescuers under the rubble. There is always the danger of disease and infection from polluted water. Everyone on a rescue team works long hours and gets little sleep. Doctors often treat patients and perform surgery in terrible conditions, but the rescue teams are tireless. Their goal is to save as many people as possible. Natural disasters involve people all over the world. Thousands can be injured. People lose loved ones, homes, jobs, and even their lives. We can help in times of disaster. We can send money or donate clothes. We can think about the people who are suffering. We can remember that we are all a part of a huge world, a world of wonder and delight, and a world of natural disasters.